Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Okay, so we continue with the last part of our study about momentum. Okay, this time we are going to learn about the application of the principle of conservation of momentum. Okay, so we look at this video.
The principle of conservation of momentum has many applications in our everyday lives.
Okay, so first we have a rifle. Okay. If you notice that the man fire the bullet, if the rifle will recoil backwards. Okay, so explain why a rifle recoil backward when it is fired. We use the principle of conservation of momentum. So when a rifle is fired, the bullet with mass m move forward with high speed v. A forward momentum is produced. Now, according to the principle of conservation of momentum, a same momentum but in opposite direction is produced by the rifle to recoil the rifle backward. Okay, so means that the mass of the bullets times the velocity of the bullet is m2v2 here, m2v2, and the mass of the rifle is m2 times v1. Okay, so the momentum of the rifle should be to the backward and momentum of the bullet move forward. Alright. Okay, so same momentum but in opposite direction. That's why when the bullet move forward, the rifle will recoil backward. Okay, we move on. Engine jet or jet engine. Okay, so the question is how jet engine is function and the gas will move backward. Okay, let's look at the animation. Okay, fan sucks air into a combustion chamber. Okay. Okay, this is the engine. Alright, air is sucked into a combustion chamber. Air is compressed until it becomes hot. So the kerosene fuel is injected into the combustion chamber and explosion occurs and produce high speed exhaust gas backward. Okay, so this is the high speed gas exhaust gas backward. And high backward momentum is produced. This will produce an equal but opposite momentum which pushes the jet forward. So momentum of the jet moved forward, and the momentum of the exhaust gas backward to backward. Right. Okay. Now we discuss the launching of rockets. Okay, so the rocket will move in the space without air, so they have to bring a liquid hydrogen gas and a liquid oxygen gas. So this is where they will mix in the combustion chamber and produce exhaust gas. Okay, so let us discuss how it works. So liquid hydrogen and liquid oxygen is mixed in a combustion chamber. The mixture explodes. The hot gases move out the rocket nozzle at high speed downward. And momentum outward produced on the rocket equals to momentum downward by hot gases. So both the hot gases downward have the same momentum with the rocket upward, but one move downward, another move upwards. Okay. This is the launching of the rocket. This exhaust gas is produced downward. So it is downward. So it will produce upward momentum. That means the rocket move Okay, so next we have another application. In a swamp area, a fan boat is used. Swamp area, we have the underneath water, we have roots from the trees, pokok bakau in Malay. Alright, so how you cannot use ordinary boats, motor, right? But we have to use the fan here. Okay, how does it work? So fan pushes air faster backwards. So the fan rotates and it will make the air push backward to produce a large momentum backward. And as same momentum produced forwards, so the boat move forwards. Okay, so look at example of the real boat. So this is the big fan. So the air is moved backward, so the boat will move forward. Okay, I think this is in Florida, where there are a lot of swamp area over there. I think they want to look at crocodile in the water. Okay, next we move on to squid. A squid propels by expelling liquid at high velocity. So we have what we call ink, black ink. Alright. How does it work? So when black liquid is expelled at high velocity, a large momentum is produced. So the liquid move this way, and the squid will move forwards. A large with a higher velocity. So a same momentum produced forward, so the squid move forward. Okay, how does the liquid move?
The squid, a member of the cephalopod class, is a strong swimming carnivore bolstering a large head, or mantle, 8 arms, 2 tentacles, and 3 hearts. Unlike the majority of mollusks, squids don't have an external shell. Instead, they have an internal shell which supports the movement of the body. Squid are also covered in chromatophores, which allow them to change colors and camouflage themselves from potential threats as seen in this video. But this camouflage may not be of use in open water, forcing the squid to find different means of escaping harm from other underwater predators. At this point, the squid turns to jet propulsion. Some squids using jet propulsion have been clocked at up to 20 miles per hour, making the squid the fastest of all known invertebrates.
Okay. Now, last part. Why does a golfer begin his swing high in the air? Alright. So the idea is, when the stick is swing high in the air, it moves with high momentum. So the stick will move with high momentum. So this high momentum is transferred to the golf ball and it moves further. Alright, a football player kicks the ball while running when taking the penalty kick, but not kicking the ball while standing, because when he runs, he gains the momentum. So the momentum is produced when the football player runs. So the big momentum is transferred to the ball, and the ball is kicked far away with high velocity. Alright, I think that's it for momentum. So we done discussing what is the meaning of momentum. We have what we call the principle of conservation of momentum, where we learn that the total momentum before equals to total momentum after, if there is no external force X. Another one is, we have 3 situations regarding the principle of conservation of momentum. The first one is inelastic collision. The second one is elastic collision, and the third one is explosion. Okay, so see you next time for the next topic. Bye. Assalamualaikum.